And now I'd like to introduce your host for the rest of the day, Aisha Bello.
Thank you. Thank you so much, Uche. Hi, everyone. It is my honor and pleasure to introduce the next speaker, Steve Holden. Steve is actually a former PSF director, has been doing Python for over 30 years. He brought about PyCon. We're here today because of him and the PSF grants team. When he's not a superstar for the community, Steve is an author of Python web programming and Python in a nutshell. He's a technical architect at the UK Department of International Trade UK and a fellow, emeritus fellow of the Python Software Foundation. Ladies and gentlemen, a round of applause for Steve Holden and his talk from supercomputer to microcontroller. Everyone, round of applause. Thank you.
Hello, everybody. Well, after an introduction like that, the talk's got to be an anticlimax, I'm afraid, but there we go. Welcome to the talk. Thanks very much to the organizers for the opportunity to present in this wonderfully impressive city of Dubai. It's my first visit, and it's an amazing place. So I've spent almost 30 years using Python in various ways. This particular picture was taken during a trip to the Amazonian jungle while I was actually in Argentina and Brazil to present at their national conferences. So clearly Python has done quite a lot for me, and I hope I've done something for Python in return. As you can see from the brief highlights there, my involvement with programming goes back, over 50 years now, I guess, and my involvement with Python's coming up for 30, so I do at least have some bona fides to present about Python. I'm actually getting on a bit now, so I don't program actively for a living anymore. You will find, if you're lucky, as you get older, that your intellectual capabilities may decline a little, but I still do a lot of programming for fun, and I'm currently working with a package called Textual, which gives you a completely new slant on the graphical user interface. It's a textual user interface package, and I would recommend anybody basically to take a look at that. So, I am old. Not quite as old as this guy here. Age is always relative, and I still feel quite young, but this is not going to be a technical talk. I'm very sorry if people came expecting a technical talk. Basically, this is simply my story about how I came to love the Python programming language and why I believe it's become such a phenomenon and so popular in the programming world. It is possible. I've been programming since before you were born. As I say, I don't do it for a living anymore because I wouldn't really be competitive. At school, I was a fairly happy kid, but I didn't really like school. I used to take time off whenever I could, and I was much more interested in activities that involved tinkering. So I would take old clocks to bits, I would find the chassis of old televisions that had been discarded. Now the clocks, they're relatively easy to understand. You see two cogs meshed together, you see them going round, you understand what's going on. So the mechanical engineering side of things, I suppose you could say, is relatively obvious. But then you look at a television chassis and it's like, well, what are all these weird components? What do they do? What are these glass bottles? Because, of course, back in the 1950s and 60s, they didn't have transistors. They were only just starting to become available. So because I wasn't particularly happy at school and because I really wanted to understand things, I had a deep need to understand things, I left school at the age of 15. And I became a trainee production engineer in a TV factory. And I spent a very happy first year in the TV factory. I was attached to the work-study department, which basically meant that I had the run of the factory. And I learned an awful lot about the way televisions were made. I learned about electroplating. I actually, as a 15-year-old, had the job of replenishing the sodium cyanide in the plating tanks. That was certainly an interesting job, particularly when I cut my finger and I was scared to death that I might have got cyanide in my bloodstream, although obviously nothing fatal happened because I'm still here. So after a year, my ambition was to work in electronics development, but after a year, the company explained that I was going to have to learn mechanical engineering because the technical development jobs were reserved for the children, for the sons particularly, of the management. But, so, after that first year, I basically thought, well, I'll try something else, and I started to look around for another job. I did actually, while I was looking around, manage to learn a few things like how to file a flat surface on a bar of metal, but I have to say it's not a skill I've ever found terribly relevant. So I joined the Bradford University Computer Laboratory in March 1967. They'd advertised for a technician, and I thought, oh, smashing, I'll be opening up the computers when they break down and fixing them. But in fact, technician was just a job grade, and what they really wanted was a key punch operator. Fortunately, the director of the laboratory must have seen something in me because he said, you seem to be going off the rails, young man. We'll give you a 6-month job and you can learn how to operate computers, which I did. Not only did I learn how to operate them, but I also learned how to program them. And my first program, which I wrote in March 1967, was to print the squares of the integers from 1 to 10. Could you raise your hands, please, if you were born before March 1967? Yeah, I'm old. Okay, so computer operations were very different in those days. For a start, there were no terminals. You had to, you had to write your program out, punch it onto paper tape with a machine called a flexor writer, and then you would load the compiler into the machine. There was only paper tape, of course, so the compiler was also a paper tape. In fact, it was 2 reels of paper tape about that size. So you'd load the compiler in, and fortunately the compiler would run in batch mode, so each program would be processed. The compiler would produce a semi-compiled output. So you'd do all your compilations, and then for the ones that hadn't produced error messages, you would then unload the compiler, load the link editor, and then you'd put the semi-compiled tape in. The link editor would read it. It would create a core image in memory. You could then run that core image, and if you were lucky, your program would produce output, which again came out on paper tape, and you then had to run it through the flexor writer to actually print it out. And if anybody's ever had to edit paper tape, believe me, you wouldn't complain about a Vim and Emacs. They're easy. So, while I was doing all this work, the second job I was given was to write a program that would convert 8-hole paper tape into 7-hole paper tape. And the reason for this was that the lab had a 7-hole paper tape flexor writer that they wanted to use, but everything we had punched 8-hole tape. So they needed a converter so that you could actually take the output from a program and then convert it into 7-hole code so that you could run it through the 7-hole flexor writer. And during that process, I had to learn assembly language because Algol's I.O. was absolutely hopeless. And during that process, I started to understand that, in fact, information is represented as numbers. Bits represent numbers, but characters are numbers, and information is numbers. And that was a very interesting observation to me. As my knowledge grew, I moved along. My next job was at my next two jobs, in fact, used the PL1 programming language, and that introduced me to things like random access files and also data structures. And at the time, I was reading a lot of the research about new languages like Snowball and about compilers and all the stuff that was going on at the forefront of computing, which in those days was a very, very small subject indeed. There were no 6,000 exhibitions or anything like that. The industry was just in its very early stages. So I realized that data structures could actually represent real-world objects, and those data structures could refer to each other recursively, so that, for example, a unit that you might think of as an address could actually have multiple lines in it. A unit that you might think of as a person could have various characters like a name, address, and a postcode, and those things could be referred to multiple times. So, very interesting observations. And after I'd been in the industry, about 6 years, I was in my early 20s, I began to realize that without any qualifications to speak of, my career was never going to move forward. So at the age of 23, I went to university, and I actually learnt about Smalltalk. I read the original papers by the Alan Kay group at Palo Alto Research Center, and I realized that this was a very interesting language. It seemed quite natural to me that you should describe data as objects which had behaviors. And that, of course, is the essence of object-oriented systems. Now, I don't know whether anyone knows much about the history of Smalltalk, but the original version, before Smalltalk 70, the original version had classes which they defined the behaviors of sets of objects just like Python classes do. But they had this rather weird message passing algorithm that allowed the objects to communicate with each other in an expression. And they used some really weird symbols. So the early versions of Smalltalk only ran on the Xerox Dolphin machine, which had that capability. It had those hardwares. So it was a very esoteric system in many ways. After I graduated, I actually got much more involved with it. So during my undergraduate career, I discovered Smalltalk, and then I saw the papers. I actually started to use Simula 2 because I didn't have a Smalltalk machine available. I did research for a couple of years. I wrote commercial systems for a couple of years. And then in the early 1980s, I became an academic and managed to get a research grant which allowed me to travel to Park to visit the Smalltalk group. I came back with a tape, and the research assistant, over the period of about 6 months, ported the Smalltalk machine to the VAX hardware, and I actually got a chance to play with Smalltalk. And I found I didn't really like it that much. It wasn't, to me anyway, at all a natural way to express algorithms. So, having been an object-oriented programming enthusiast for, by that time, going on for 10 years, I moved on to other things. I became a technical support specialist at Sun Microsystems. I started a company called Desktop Connection to sell electronic publishing systems. I did some consulting. I did some training. And increasingly, the training work that I was doing started to take me across the Atlantic, particularly to the Washington, D.C. area. And one of the courses that I was asked to teach had a complex setup which was actually directed by languages written in Python 1.4. So I got a chance to see Python and felt curious about it, but didn't start investigating. It was only after I moved to the States in 1994, was it? that I went to a restaurant. I was asked to wait for a table, so I meandered into a bookstore, and I came across a book called Learning Python. And within 3 days, I think, I pretty much knew that Python was a winner. It was not exactly love at first sight, but certainly I had found, oh, sorry, we skipped over the short interlude, didn't we? Yes, I did move to the States. But yeah, within 3 days, I knew that Python was a language that I wanted to invest a lot of time in. And I thought, well, 20 years ought to do it. But you do realize that technologies don't win by accident. It's very rarely a case of the best technology winning out in the marketplace. Technologies have to be promoted, and I decided that I would spend a lot of effort to try and promote Python. Why was I doing that? Well, why did I like Python? Basically, because Python is elegant. It has an economy of design which I think is beautiful. It is Smalltalk-like in various ways, so it uses late name binding like Smalltalk does, but it has a much more sensible syntax. It has usable string handling. It was slightly less usable in the Python 1.4 days. It has usable string handling. It had a good range of data types, and so I decided that it was the language for me. Now, late name binding is both good and bad, of course. Late name binding is used in dynamic languages. Static languages basically bind names to areas of memory at compile time, which makes them efficient because they don't have to compute the locations at runtime, whereas Python binds names to values rather than memory locations at runtime. This makes polymorphism very much easier to implement, but it also means that variable lookup is somewhat slower. In fact, variable lookup isn't required in static languages. All that computation has been done during the compile stage. So the emphasis on readability was very important to me. There are effectively two design philosophies in language design. You can either make it easy to write good programs, or you can make it hard to write bad programs. And basically, they jokingly say that Python is a language for consenting adults, in that you can, in fact, shoot yourself in the foot if you want to. But this language for consenting adults lets you do most of the things you want without having to worry too much about the constraints of the language. So in designing Python, Guido van Rossum took the best of other languages. And he certainly took C libraries, for example. Many of the basic functions in Python are based on the interfaces that were provided by the C libraries that implement them in the underlying layers of the Python interpreter. He took comprehensions from Haskell. We took hashes from Perl and made them into dictionaries. We took our scoping rules from Lisp when we finally got them straightened out. And he's built a language which all seemed extremely natural. Whoops, sorry, went backwards instead of forwards. So simplicity means ease of use. And if you look at this, this is the archetypical introductory C program, Hello World. And there are a lot of questions that the beginner is bound to ask themselves when they look at that program. Include, what are we including there? What does the hash mark do, and why have we got angle brackets there around the name? Why is there a function called main? Oh, and what's a function, by the way? And why do we printf something instead of printing it? And why do we have to return 0? That is not, I would argue, a terribly easy program to understand. Whereas in Python, the archetypical hello world is just that. You print hello world and you're done. No structure required, couldn't be easier. So the Python language basically draws people in. The other thing is it can handle exceptions, and having had to cope with poring over core dumps from time to time in my early programming career, I was very happy to find that we could handle most error conditions, and there's a little recursive function which will recurse indefinitely, but that code runs perfectly fine. The code recurses indefinitely until it gets to the limit of recursion, and then a recursion error exception is raised. It prints a message and it finishes. No core dumps, no nothing like that. And one of the basic ideas behind Python is that you should never have to cope with the ugly details of the underlying machine representation. So, the reason people use Python, I would argue, is not because they're interested in efficiency. I would argue that utility to the programmer is of much more value than efficiency. And as you can see, over time, Python started out with a relatively high utility and a relatively low performance. But over time, the increase in utility has maybe tailed off a little bit, but the increases in performance, thanks to people like Mark, are really moving forward. And it's a very usable and now quite an efficient language as well. Not only that, but it plays well with others, so that it doesn't try necessarily to be best at everything. It accepts that other languages may be more suitable for certain tasks, and so it tries to play with them. For example, the NumPy program that we're all, or not all of us, but that is so heavily used in scientific work, the NumPy program is effectively, at its core, a collection of algorithms that were written in C and Fortran, typically between 30 and 40 years ago. The numerical problems themselves aren't new at all. So the other thing is that it gives you direct access to the operating system features. And one of the things I'd hated about Smalltalk is it's effectively a closed world. It didn't accept that there was an operating system or a file store. You weren't able to communicate with these things, so everything had to happen within the scope of the Smalltalk virtual machine. That's not the case, of course, with Python, because you can actually access platform-specific features as well if you want, although clearly, if you want your code to be portable across different architectures, it's not a terribly good idea to make heavy use of them. The other thing is that Python has now decided that perfection isn't what we're looking for. What we're really looking for is a language that is good enough, that will produce adequate performance, and is optimized for low development times. And Python is well known as a fairly rapid development language. So not only that, but Python's now got a really interesting way to incorporate future code in the future module. And the thing about the future module is that it can not only import functionality like most standard imports do, but the future module can actually change the behavior of the compiler, which is exactly why they have to be the very first lines in your code if you're going to import features from the future. So, for example, back in the Python 2 days, and in fact I think even in 2.6, you know, we're talking about print being a keyword, but even in Python 2, you could import print function from the future, and once you'd imported that, print was no longer a keyword, it was simply another variable, and to print things, you would actually call the print function, which was compatible with the Python 3 print function. So it offers ways for people to move forward while flagging that the features that they're using aren't necessarily yet set in concrete. And I think basically the fact that Python has enabled so many useful libraries is a testament to its utility and now, of course, to its speed. So there are things like Django and Flask, which are well-known web environments. There's IPython. All the stuff on the left of that slide is curated by the PyData Foundation, and they're doing an excellent job. So the amount of Python software that's available is increasing from day to day. Not only that, but now we have MicroPython, which is able to run on pretty much the very smallest pieces of computing hardware that we've got. MicroPython is an excellent but tiny implementation of Python 3.4, but they've also brought various other features in that have since been implemented. So it has async, and it will actually allow you to write asynchronous code on your microcontroller. And it has the F strings, so formatting is relatively easy. And the reason that it's so popular in the microcontroller world is precisely because of its utility to the programmer. And thanks to MicroPython, I've achieved my dream of being able to write interrupt handlers in Python. But not only does it run on microcontrollers, it runs on graphics processing units as well. And so if you really want to maximize your performance, you can use GPU hardware and a relatively high degree of parallelism to solve your problems. And if a GPU isn't enough, then Python can actually quite easily run on the largest computers in the world. And in fact, one of the groups that I've worked with in the past are an astrology group, and they are daily dealing with huge graphical images of literally gigabyte size. The data that comes in from astronomy, you simply wouldn't believe the volume that they have to cope with. And Python has coped with it quite happily. So, in summary, the mission I adopted to popularize Python has actually added both purpose and enjoyment to my programming career. It's probably subtracted some income because I've actually put a lot of effort into open source development, which, as we all know, isn't necessarily particularly profitable. But as Brett Cannon summed it up, somebody once asked him why he used Python and why he still used Python after such a long time. And it's a fairly famous quote. He said, I came for the language and I stayed for the community. So I hope this explains why I'm in love with Python, and I hope it also explains the popularity of the language. Python has brought me into contact with many wonderful places and people, and of course without it, I probably wouldn't be in Dubai either. So I don't know whether we have any time for questions, but if you want to see the slides again, then they are available at GitHub. Thanks very much for listening.
Wow, everyone, a big round of applause. Thank you so much. That was amazing. We have time for like 1 or 2 questions. Oh, yes, please, microphone. I can just probably.
Hi, my name is Yasmin. I would like to thank you.
Microphone a little closer, please.
Yeah, my name is Yasmin. Thank you for the presentation about Python. I just want to tell you that in Arab world we have books about Python. We have make it in Arabic to educate Arab world about Python by the global village in Oman. And we are proud of this, and exactly I acknowledge you, and we are thankful for Python. So it's also in Arabic here. Thank you.
Thank you so much. Question.
Thank you very much. I think you should really vote. You should really be thanking Guido van Rossum and all the people who've created the language. But I've certainly been very encouraging of the community around it, and I think that is part of the reason for its popularity.
Okay, maybe just one super short question. Yeah. Short, please. Thank you.
Hi.
Hi.
My name is Zahir, and I am a junior programmer in Python. I have a question that's most of the people asking us, high school guys, and you mentioned that you got graduation in old days. And do you recommend that without graduation people should learn Python and it works for them?
Sorry, do I find
Yeah, I mean, there's somebody who didn't get any college or university degree.
Ah,
So he should learn Python or not?
you mean do you need a college degree to use Python?
Yeah.
Definitely not. No,
Yeah.
definitely not.
Thank you. That's very...
Don't assume. Oh, I tell you, man, I taught in the university for 5 years, and the thing that depressed me most was how bad you could be and still obtain a degree. So I'm no great respecter of academic qualifications.
Thank you so much.
Thank you
Another
very
round
much.
of applause, everybody. Thank you.